Hi, I'm Kirk Evans, Principal Premier Field Engineer for Microsoft. In this section, we'll take a look at building developer-hosted apps for SharePoint 2013. Cloud apps, developed as developer-hosted apps, in other words, those apps that are not Windows Azure auto-hosted, they use the same process as Windows Azure auto-hosted apps when you're developing them. The big difference, though, is that all pieces must be deployed by the developer and manually wired up. For example, a multi-tenant application may reside in a single Windows Azure instance. Users could acquire the app that leverages the multi-tenant application via the marketplace. Once installed or added to a SharePoint site, some account configuration data can be entered to configure the user's partition in the hosted service. For instance, I may need to configure separate tenants within my website to accommodate new customers. An example might be an ISV solution where I need to register companies and customers separately within my existing infrastructure. The developer must take into account the architecture and infrastructure configurations to get this deployment to support the model. The life cycle of building provider-hosted apps kind of looks like this. You'll create your cloud app, and to do that you'll start to use developer tools to build and debug the app using your technology of choice, whether it's Visual Studio or Eclipse, and you'll register the app with Access Control Services, ACS, inside your Office 365 Azure tenant. And then you'll configure the OAuth and the app config for your application. In the SharePoint package you use Visual Studio to build the app package. You'll focus on the app entry points, such as custom actions or client web parts. So again, we'll need to focus on how will the user actually interact with our app and be able to launch the app from the SharePoint site. We also need to carefully consider the app web context. When we create a tenant scoped app, we don't receive an app web for that. So we'll need to consider if we are pushing data to be stored inside SharePoint. And finally, you'll need to test on the developer site. The lifecycle of deploying a provider-hosted app is fairly straightforward. You deploy the app to the production app host. So you would deploy to your own infrastructure, whether it's a website out in Azure or your own server somewhere. You'll then take the SharePoint package, you'll verify the production OAuth configuration, and verify any production references that you have, such as any database storage that you may have in production. And finally, you'll publish the app package to either the Office Marketplace, or you can also publish to an app catalog internally at your site to make it available for users to install inside their SharePoint site. Now, looking at upgrading provider-hosted apps, we need to consider that all previous versions are deployed and possibly still installed. So don't do some common sense things like don't delete pages that may be referenced from previous versions. And then on the SharePoint package side, we'll need to understand how the upgrade happens. The upgrades are never forced on users, and upgrades must be initiated by the tenant admins and or the users. Because upgrades are never forced and are initiated by the tenant admins, and because previous versions may be in use, you should always test upgrading from any version to the current version. Let's take a look at building a provider-hosted SharePoint app. In this demonstration, we'll create a provider-hosted app that communicates to a site that has a trust to Azure ACS, and we'll inspect how we can use the client ID and client secret to configure the app, but also we'll use that as a means to inspect how the context token is passed to the app, how we can extract the refresh token, and use that refresh token presented to Azure ACS to obtain an access token. So to get started, we'll go to windowsazure.com and click the portal link, and that'll take us to manage.windowsazure.com. And then from there, I'll be able to go to the websites node, and I'll create a new website. And I'll use the quick create option, and the URL will be Azure Provider Hosted www.azurewebsites.net. Choose a region that's close to you and create the website. What's created for you is an empty website. There's no implementation. We'll need to use Visual Studio to provide the implementation, and we'll upload that to Azure. To do that, click on the new website that you just created, and you'll see a link to download the publishing profile. Simply click that link and then save that in your downloads, and we open the downloads. We'll be able to see that the publish settings was just downloaded from the Azure site. We'll use that from Visual Studio in order to publish the website back to Azure. Now the next thing we'll need to do is we'll go into Visual Studio and we'll create a new app. And this will be an app for SharePoint 2013, and we'll call this our Azure Provider Hosted. Choose OK. Provide a friendly name, a URL for debugging, and in this case we need a website that is connected to Azure ACS, so we'll use our Office 365 developer site for debugging. And finally, the provider hosted model will be the hosting type for our app. Choose Next. We're then prompted if we want to configure this either using server-to-server communication or using a client secret, which requires a SharePoint farm that is connected to Azure ACS. And in this case, this is the option we'll choose as the default, use a client secret. We'll choose Finish. Visual Studio then creates two projects for us. One will be the app project that contains the app manifest and the icon. The other one will be the actual ASP.NET web application. So first, let's go look at the app manifest. In the app manifest, if we look at the code view, we can see familiar properties such as the title and start page. We can also see that our app principal is a remote web application principal, and the client ID is currently set to *, which allows for easy debugging. What we'll want to do is not just to debug through localhost, but actually deploy the website to Azure so we can see that our Azure website running somewhere else can communicate to Office 365 and how that's done. So to obtain this client ID, we'll need to go to our SharePoint site. So let's go into our SharePoint site. And using the URL, such as apps2013demo.sharepoint.com, you'll go to _layouts/15/appreg_new.aspx. So we'll copy that and put that into Notepad really quick just so everybody can see it. And again, the URL is _layouts15/appreg_new.aspx. So when we go to that page, we're prompted for an app ID, app secret, title, app domain, and redirect URI. We can generate the app ID and app secret, and the title here we can provide such as Azure Provider Hosted. The app domain will be Azure Provider Hosted.azurewebsites.net, which is the URL that we just created a moment ago. And then we'll copy that and we'll provide that as an HTTPS endpoint. So you need HTTPS in order to do this. /pages/default.aspx will be the page that is generated by Visual Studio. Finally, we'll click Create. When we click Create, then the app will be registered, the app principal will be registered for us. So now we can go back and grab the app ID, go back into Visual Studio, and change this asterisk to the actual app ID. The next step in the configuration is we'll need to go into the web.config. And in web.config, we also see the client ID and client secret. A client secret is already there. We'll need to replace that value. But first, let's provide the same client ID that we just provided in the app manifest. Next is we'll go back to the website and we'll grab the app secret, the client secret that was just created for us, and we'll replace the default value that's there with the correct value. So now our app will be able to use the client ID and client secret to be able to communicate to Azure ACS. And how it does that is by using OAuth. So let's go into default.aspx.cs and look at first the default code. The default code uses the context token that was passed as part of the initial request to our app. So provided this context token, we can easily provide that context token to this method, getClientContext with context token, in order to obtain a client-side object model client context. Well, that kind of hides a lot of the implementation details, so what we're going to do is we're going to change this code around a little bit to help you understand how the context token, refresh token, and access token all work together in order to authorize our app. Let's move this line of code first. All right. So the host web, we still want to be able to get the host web URL, but we're also going to need to be able to get the host web as a URI. And so we'll say is equal to new URI, and we'll pass in the host web. And that we'll be able to use that because we'll need to get some properties such as the authority from that URI. The next thing is we have the context token, and we extract that from the request, and that's simply a string. So we can actually just response.write h2. Oh, missed an open there. h2, and we'll say that this is the context token that was passed to our app. And then we'll just append the context token itself. Okay, so we write out the context token. The next thing is we need to be able to get the refresh token. The refresh token is contained within that context token, but we don't have to really do the work to extract it. There's already a helper method inside token helper that will provide that for us. And that's token helper dot read and validate context token. And we'll pass in the context token that we just extracted from the request. And then we'll also pass the request.url.authority. And then we'll store that in a SharePoint context token type. And we'll call that CT. So now that we have the SharePoint context token, we can now say CT dot, and we should be able to access some other properties such as the refresh token. So we can actually just say here, response.write h2 refresh token, so we can inspect the value of that and see that it actually is there, and that's just a string value as well. So the next part that we'll want to do is after we obtain the refresh token, we'll want to present that to Azure ACS in order to obtain the access token. And in order to do that, token helper again has a method to do that. It's called getAccessToken. And you will need to provide the SharePoint context token that we just provided, as well as the host web URI .authority. So we provide in that authority, and once we have that, we'll be able to say that that is now provided us the access token. So string access token is equal to the result of that. Once we have that, then we can again use another response.write. This time, instead of writing the refresh token, we'll write out the access token. So there we go. We're past the context token. We extract the refresh token, and then we call Azure ACS to get the access token, and then what's returned back to us is the string access token value. Once we have the access token, we can now go back and form up a client context. All of this implementation was comfortably hidden from you with the default call to get client context with context token. However, if you want to be able to see how to do this by extracting out the access token yourself, then we can change this method. Instead of using the get client context with context token, we'll call get client context with access token, and we'll provide the target URI will be the host web that we're going to call, and the access token value that we just extracted. And now that we have the client context that was formed not based on the context token this time, but rather based on the access token, we now use client-side object model call to be able to write out the title of the web that hosts the data, that hosts the site. Now again, we're just using the long form. The much simpler API to use was the get client context with context token, which was extracted here from the request. However, if you want to see how to use the context refresh and access token, then these methods are provided as part of the token helper class for you. And now we should be able to run, but before we do, we'll need to make sure, because we're actually going to deploy this to Azure ACS, we need to change the app manifest to point to, instead of remote app URL, we're going to tell it explicitly to point to Azure provider hosted.azurewebsites.net/pagesdefault.aspx. And further, remember how we downloaded the publish settings? Well, these publish settings will be used with this website to push this from our local Visual Studio out to Azure. So first is we'll go into web.config, and we'll go into the release version, and we're going to remove this transform. And that will just avoid that we have to re-enter the client ID and client secret on the portal. Next is we'll right-click the website itself and choose Publish, import a profile, point it to the publish settings that we downloaded previously, and choose Publish. This pushes the website out to Azure, and now since the website is sitting in Azure, then we'll be able to communicate to the Office 365 site. So to do that, we'll need to deploy our app, and to do that we simply will hit F5 because our start page points to our Azure site. So we'll choose F5. We're prompted for credentials for our Office 365 site. Provide the credentials, then the app is uploaded, installed, and then in just a moment Internet Explorer will launch and the debugger will attach to Internet Explorer. And since the website is actually running in Azure, we won't be able to server-side attach to that to inspect the tokens, but rather we'll use the HTML output from the app to see the tokens as they're passed. Again, we log into our Office 365 site. We're asked if we actually trust the app. We do. And then finally, our app is rendered, and we'll be able to extract not only the context token, the refresh token from the context token. We go to Azure ACS to obtain a valid access token, and then finally the title of our website is written right here. So that was a quick example of how to use the context, refresh, and access token, how to create a provider hosted app that communicates to a website via the client secret and the client ID using a SharePoint site that has a trust to Azure ACS. In this section, we took a look at provider hosted apps, and we took a look at the life cycle for creating, deploying, and upgrading an app, and then we saw an example of a provider hosted app in action.